Learning to multiply multiplies our students' learning. So here I've got an example of what I would do when my students are struggling with multiplying by 2, doubling 7. So my students are of all ages, so older students, younger students, and all I say to them is mirror me. So when they mirror me, they put their left hand up, which creates the 10 with my right hand, and they mirror my 2 with their 2. And so this is 10 plus 4 is 14. So that way they can see that when I double 7, I get 14. Hi, my name's Christine, and I'm here from Maths Heroes to do a video on doubling, which is a keystone for our students to be able to be successful in multiplication. A lot of the time, I have learned when I would draw this picture as a secondary teacher, I would be drawing a factor tree and I would say 7 sevens are 49, or I'd ask what are the factors of 49. I've since learned that that is used in primary school as a part whole model. So rather than my 7 sevens are 49, that they would see that as part whole like that, there would be arrows going and, all that sort of stuff. And that wasn't particularly helpful to my students. The idea of the blocks down here is fabulous. However, I think even with just a simple little tweak, so you can use blocks, you can use the multiplicative thinking blocks that I've got to model this, that if you've got a 5 and a 3 and a 2, you can see the equals sign. You can actually even start to develop proportional reasoning in that 3 is more than half of 5. And I've had students who struggle with maths actually be able to say to me, Miss, I can see that 3/5 plus 2/5 equals 5/5. So they actually can partition that in. They can sort of see that. And I go, that's fantastic because that's huge. So there's a lot of benefit in thinking about the way we represent our the abstract ideas how we want them to represent their thinking. So up here, I might choose to model this one in my tens frame if that's how they've counted on. So in that instance, they have taken 3 from here to make this 10, and then this left over bit will be 4. And I know that 10 plus 4 is 14. You might have students that are ready for a number line. So I might, instead of doing that breaking down, I usually start with that. When I draw it like this, I say, oh, okay, well, let's have a look. You're at 7 here, and to get to 10, using a number line, to get to 10, I would have hopped to 3 to get me to 10, and then I would hop another 4 to get to 10 plus 4 is 14. You can also show them that within here, there's a 5 and a 2. I'll just do it down here so that you can see it a bit better. Not that I would draw it that way normally, but there's a lot on the picture at the moment. And anyway, so there's the 2 5s and the 2 2s, which is that picture. So there I've got 10 plus 4 equals 14. And either way, or any other way, that you can also show that the 7 has 3 groups of 2 and a single 1 in there. So there's lots of different ways. I can also show 1, 2, 3, 4, 5, 6, 7. I can show that 7 2s are also 14. And that's really important. When I say 2 7s are 14, later on if they have 2x equals 14, then they know that the size of the unit is a 7. We have no standard as such with describing whether it's multiplied by 3 or 3 multiplied, so multiplied by 2, 2 multiplied. So whichever way we talk about it, we want those students to be fluent in that, because it's not actually about the size of the unit. The unit does not change how numbers work together. So here I've got 7 hours, 7 hours is just 14 hours. 7 eggs plus 7 eggs is 14 eggs. 7 cats plus 7 cats is 14 cats. 7 twelfths plus 7 twelfths is 14 twelfths. 7 ones plus 7 ones is 14 ones. 7 tens plus 7 tens is 14 tens. Use a number slider to model that one. It's great. We only rename and regroup when we reach an agreed unit. So we might say that that's actually 12 twelfths plus 2 more twelfths. And we would say that that's 1 and 2 twelfths. Or we might say, oh, well, we call that a dozen eggs. And then I've got 2 more individual ones because I know that there are 12 pieces in a dozen. All right. So the big idea here is that the size of the unit, whatever I'm counting in, doesn't change the way that the numbers relate. 7 and 7 is always 14. Doesn't matter what I count in. Some of the resources that I've created over the years to help with that. The first one's simple exit ticket idea, or you can use it however you like. Every day you double one number between 0 and 100. Not all doubling is created equal. So that first column with no regrouping is where you have to start because there's no regrouping needed. If I double 22, I get 44. If I double 33, I get 66. Then you've got this first digit that creates regrouping. So if I was here at, let's go 73. If I was at 73, I know that double 70 is 140. So I'm going to double that. I'm going to get 140 plus double 3 is 6. So it's 146. That's actually easier to hold mentally. Whereas when you regroup on the second digit, which is where the doubling occurs, say I've got 36. Well, I've got 2 lots. So there's a 36. I've got 2 lots of 30, which is 60, and 2 lots of 6, which is 12. So I've got altogether 72. So that requires the renaming and regrouping of 60 plus 12 into 72. The last one, for example, if I've got 68, if I was going to double 68, I could say, okay, well, that's going to be 120 plus 16, 136. How else could I think about it? Well, I actually know that 68 is 70, take away 2, and I've got to do that twice. So actually that's just 140 minus 4, which is, again, 136. It's the flexibility that you can start to play with the numbers and see what works best for your brain. So I've put those cards to match each one. So, I've grouped all of the ones in blue. They're together. They're the ones that require a second digit regrouping or both digit regrouping. And you can print them on different coloured card if you want. Kids can pick out whichever colour that they want for the day. If they're feeling for an extra hot, they might take a purple one. If they're going for mild, they might take a green card. Another one, you can slip this into a plastic window sleeve idea. So that's the one with, my number is, and pick a digit, if they're just starting out. And you can double it and you can see it, with the blocks, with the tens frame, with another box. I've got another one that I created a while ago and I had some pictures with it. You can also put some sentences with it here at the bottom as well. Again, can go in a plastic pocket if you want. And the other one that I love the idea of, and I've done it time and time again, is this bingo idea. However, when I created this bingo, the caller card, right, so this is what you're calling from, right, I actually found you need, okay, so you might want the students to cross off the 2, for example, if you call that, but that doesn't make them think about calling. So actually what you want to do is call out 1 and then they have to say, well, 1 is 2, and go and work like that. So instead of having to do that, so call out 4 and then they have to say, oh, double 4 is 8. I actually just put it in Word and I've created a caller card. And basically you call out 15 and the student crosses off 30. So you cross that off, and that makes it a lot easier to keep track of what you've called out, what they should have crossed off. There are lots and lots of games to play with doubling. It is such a keystone skill. The teachers at a later stage will thank you for creating this sort of model here with the 7 and the 7 and the 14 in a box, because if I've got 100% here, this is 50%. Right? So what is 50% of 14? It's 7. What is, if a number has 50% equal to 7, what is the 100%? That's the other version of it that I could do. So there's lots and lots and lots in there as well. I hope this video has been useful. I look forward to seeing you at the next one. Thanks for watching. Bye for now.